Okay, this is section 5E in the Math 111 class entitled Correlation and Causality. And this is video 2 in this section. In the first video for this section, we looked at correlation. In this section, we're going to look at causality. And just recall in video 1, we also said just because there's a strong correlation between two variables does not necessarily mean that one variable caused the other. So correlation does not necessarily equal causality between those two variables. Okay, in video 1, we looked at correlation, and this is just sort of a recap of what we learned there. We talked about correlation can either be positive, negative, or no correlation. If it's a positive correlation, as one variable increases, the other increases. If it's a negative correlation, as one variable increases, the other one decreases. Okay, also in video 1, we said when we're doing a correlation study, a good place to start is to look at a scatter plot of the data. So when you're doing a scatter plot, on your horizontal axis, in all of these, you would have your suspected cause, so that's along these axes. On the vertical axis is going to be your effect, and that's of course going to be along all of these vertical axes. And you're looking at the pattern that the points make. So in this first one here, the pattern looks like a straight line going this way. The second one should be a straight line going this way, and the third one looks like no correlation at all. So this second one, let me erase some of these because it should look more like a negative correlation here, which means that they're this way. Okay, so that is the next step, is to look at a scatter plot. The next thing we looked at with correlation was the strength of the correlation. And we have a measurement, and it's called the correlation coefficient, and we use R. And we said when R is very close to -1, it has a strong negative correlation. If it's very close to +1, it has a strong positive correlation. And if it's close to 0, it basically has no correlation. There is a statistical test to determine if that correlation is statistically significant. We're not going to study that test, but I want you to be aware that that does exist so that we can objectively analyze whether a correlation does exist or not in our study. Okay, the last thing in video 1 that we kind of looked at was explanations for this strong correlation. So if you find a strong correlation between two variables, it might be due to a coincidence, a common underlying cause, or a direct cause. In this particular video, we're going to analyze the direct cause and determine with some guidelines whether one of those variables actually caused the other. So like I said, in this video, we're going to look at causality. And the first thing we want to look at then is some guidelines for establishing whether causality exists between the two variables that were correlated. So the first one is to look for situations in which the effect is correlated with the suspected cause even when other factors vary. Okay, so to illustrate this first guideline, I want to go back to the example that we looked at in the previous video was automatic weapons, and the number of automatic weapons was our suspected cause, and whether that caused the murder rate to increase, and that would be our effect. So remember when we did the correlation study, we found that it was a very strong positive correlation. This was our R value. And the other factors that I'm going to identify that could actually cause murder rate to increase are drug abuse, DUIs, domestic abuse, and I think you could probably think of a lot more, but these are just some factors that I want to talk about. That when they vary, that correlation still exists. That's what we want to look at first when we're looking for causality. So our second guideline for establishing causality is among groups that differ only in the presence of the suspected cause, check that the effect is similarly present or is it absent. So what you want to try to do is isolate that suspected cause from the other factors, which isn't always that easy. So you could do that possibly by doing a new study, or you could look at the data that you use to establish the correlation and see if within any of those data parts or pieces that would occur that some of those other factors were missing, and then redo the correlation trying to isolate that suspected cause and see if the same correlation exists. Okay, so the third guideline is to look for evidence that larger amounts of the suspected cause produce larger or smaller amounts of the effect. So it's going to be larger amounts are going to produce larger amounts if it's a positive correlation. Larger amounts are going to produce smaller amounts if it's a negative correlation. So in our example, we might want to look at states where the number of automatic weapons is greater than the original data that was used to establish the correlation. And then we want to say, does the same effect occur on the murder rate as it did from the original data set? The fourth guideline for establishing causality is if the effect might be produced by other potential causes other than the suspected cause, make sure that the effect still remains constant after accounting for these other potential causes. Okay, so going back to the example that we've been following with the automatic weapons versus murder rates, the potential causes that we identified previously in this section were drug abuse, DUIs, and domestic violence. And I'm sure you can think of other ones. So what you would do with this guideline is you would try to remove any of the murders that were a result of these other potential causes. And then you want to say, after you remove them, does the correlation that you studied and found to be true still exist between the number of automatic weapons and the murder rates? Okay, number 5 is, if possible, test the suspected cause with an experiment. Now, I'm going to show a way that we could do this, but I'm not sure how ethical this would be to do it with an experiment, so just keep that in mind. But you would set up several small areas, varying the number of automatic weapons in each of those areas. And then you want to determine if that correlation between automatic weapons and murder rates still exists given this new set of data. So the sixth and final guideline for establishing causality is to try to determine the physical mechanism by which the suspected cause produces the effect. Okay, in our example, the physical mechanism, I believe, would be the automatic weapon or the owner of the automatic weapon. But in other examples, it might not be the same thing as the suspected cause. But in this particular case, it is. So the next thing we want to talk about is how confident we are in the causality. Okay? And we want to look at the confidence based on the 6 guidelines that we looked at in the previous slides. Okay, so causality, as you can see, is kind of a subjective term. In other words, there's no real objective test to do with the data to establish causality. You just need to look at it critically and think critically and determine if you think that cause is actually there based on the guidelines we went over, as well as maybe some other things that you might think of on your own. Correlation, which we studied previously, there is an objective statistical test to establish whether there's a correlation there. Just remember that if there is no correlation, then you don't even want to go to the causality. So correlation comes first, and then once we get correlation, we can look at whether there's a cause. Okay? No correlation, no reason to do causality. Okay, a good example of causality and where it occurs is in a courtroom situation. And the first step in a criminal investigation is looking at a possible cause. And a possible cause is a reason to start an investigation due to a strong correlation. So once you establish a possible cause, that leads to the next level, which is your probable cause. The probable cause is a general reason for a judge to grant a warrant for a search. So after a possible cause, you go to the probable cause level. And then lastly is what we call cause beyond a reasonable doubt. And cause beyond a reasonable doubt is the usual standard for a conviction. So what the jury needs to determine is, did the prosecution show beyond a reasonable doubt how and why the suspect committed the crime? And these are all terms that you're familiar with, and it's a good example that looks at causality in the courtroom system. This next slide would be the next step if you were doing a full-blown correlation, causality, regression analysis. So the regression analysis is the last piece. Once you're confident of the correlation and the causality, you want to study the scatter plot. And I went back to the example with the GPA as our effect, and the number of classes missed was our suspected cause. And we had a series of dots. And then what happens with regression analysis is that statistically, the equation of a line is determined, the y equals mx plus b, based on the best fit to those dots that represent a GPA and a number of classes missed. Okay? This line of best fit is then used for predictions in the future. So if this holds, I can plug in the number of classes that you missed in a semester and predict what your GPA is going to be. So this would be the next step. This is not covered in your book, but I just want you to be aware that that would be the next step in an analysis, which is predictions. This concludes section 5E, which looked at correlation in video 1 and then causality in video 2, which is this video. And it's also the last video in chapter 5, which was titled Statistical Reasoning. And in this chapter, I hope that you learned to think critically in statistical applications.